Alright, welcome to Chapter 11, Section 1, Angle and Line Relationships. So we're going to start off with pairs of angles. The first pair we have is called vertical angles. Vertical angles are two pairs of opposite angles that are formed when two lines intersect. So if I were to draw out two lines, like this, we can call it line L and line M. These two lines that intersect, or they cross, form four angles. 1, 2, 3, and 4. The vertical angles would be angle 1 and angle 3 because they are opposite of each other, and angle 2 and angle 4. In addition to them being opposite, it says that they are congruent. We're going to see this word come up quite a bit in the chapter. Congruent means equal, and it has its own symbol. Looks like an equal sign with a little squiggle on the top. So I can say angle 1 and angle 3 are vertical, and angle 1 and angle 3 are congruent. Angle 2 and angle 4 are vertical, which means angle 2 and angle 4 are congruent. So they're the same exact size, they are equal. The second pair we have are called adjacent angles. And adjacent is just a fancy word for next to. So adjacent angles are two angles that have the same vertex between them, and they share a common side, but there's no overlap. So if I were to draw out a picture like this, I have two angles, angle 5 and angle 6. They share this common vertex and they share this common side, but they don't overlap. They both have their own space. So I would say angle 5 and angle 6 are adjacent. And again, I said when you think adjacent, think of the words next to. So in the example above, where there were vertical angles, I could say 1 and 4 were adjacent. I could also say 2 and 3 are adjacent. So again, vertical angles are opposite from each other. Adjacent angles are next to each other. The next two pairs have to do with measure. First one is complementary. And the second one is supplementary. So, complementary angles are angles whose measures add to equal 90 degrees. So if I drew out this picture, and I said I have two angles, 7 and 8. You might see a box that tells me that I have a right angle. So I know that angle 7 and 8 are complementary because the measure of angle 7 plus the measure of angle 8 equals 90 degrees. Now if you see the M in front stands for measure, I would read this, the measure of angle 7. So they could both be 45. I could have one being 30 and 60. I don't know exactly what they are in this case, but I do know they're complementary. They add to 90 degrees. Supplementary are two angles whose measures add to 180. So 180 degrees would be a straight line. So I could say this is angle 9 and angle 10. I could say the measure of angle 9 plus the measure of angle 10 equals 180 degrees because they're supplementary. So 4 angle pairs here. The first two had to do with position. They were either next to or opposite of. And the last two had to do with their measure. But they're all different angle pairs. Pairs of angles can be classified by their relationship to each other. A special case occurs when two lines intersect to form right angles. We call these lines perpendicular lines. So if I have two lines, again, maybe we'll call it line L and line M, and they form a right angle, well, I know that they're all going to be right angles because vertical angles are going to be congruent. So these two both have to be 90, okay? And I know that the angles next to each other, adjacent, have to be supplementary because they make up a straight line. So if I have one right angle, I actually have four. I can write it out like this. Line L is perpendicular to line M. So instead of actually writing out is perpendicular to, we have that fancy little symbol. So this one says angle R and angle S are complementary. Now that was one of our angle pairs. Complementary meant that they add to 90 degrees. So just based off of this first sentence, I have angle R, angle S, and. So I've done my circling and underlining, now I'm going to write it out. The measure of angle R, and would tell me to add the measure of angle S, are complementary, and complementary meant 90 degrees. So if I keep reading, it tells me the measure of angle R is 65.3. So where I see the measure of angle R, I'm going to plug in 65.3. And now I can solve for the measure of angle S. I'll just subtract 65.3 from both sides. To find that the measure of angle S is 24.7. So some of you will be able to do that in your head, but remember we got to show our work. Two lines that never intersect are called parallel lines. And we've talked about these a couple times in the last few chapters. So if I have parallel lines, they're never going to cross. When we were graphing them, that would mean they have no solution. Okay, let's say S and T. If they're parallel, they're going to have this little darkened arrow on both of them. So my lines aren't perfectly straight there, but that would tell me that they are perfectly parallel. A line that intersects two or more parallel lines is called a transversal. So if I had these parallel lines, and I had another line that went through them, I could call that R. That would be my transversal because it goes through two parallel lines. Just like with perpendicular, we have shorthand for parallel. I could say S is parallel to T without actually having to write it out in words. So we're going to have these special angle relationships, which I gave a big space for here. Let's actually draw our picture on the next page so we have it next to our chart instead, just so it's a little bit easier to see. So we're going to use this same picture for all of these boxes to fill in. So I'm going to have two parallel lines. Okay. And I'm going to have a transversal. Goes through both of them. J K, and L. And I'm going to have each of these pairs. So I look at this and I see that I have 8 angles. 1, 2, 3, and 4. And then I have 5, 6, 7, and 8. So 8 angles formed by my 2 parallel lines in my transversal. So first thing to notice is I have angles that are inside my parallel lines, and then I have angles that are outside my parallel lines. So the 4 interior angles lie between or inside the parallel lines. That's supposed to be a period. Oops, you can fix that though. So the ones that are inside would be angle 3, angle 4, angle 5, and angle 6. The 4 exterior angles lie in the 2 regions that are not between. We could also say they're outside the parallel lines. That would be 1, 2, 7, and 8. So once you've determined which ones are inside and which ones are outside, we have 3 different types of pairs that we can make with them. The first one is called alternate. Oops. Let's fix that. Interior angles. Okay, so I know that by the word interior, I'm looking at 3, 4, 5, or 6 only, and they need to alternate. That means they are on opposite sides of the transversal. So my alternate interior angles would be angle 3 and angle 5, because 3 and 5 are both inside and they alternate sides. I could also say angle 4 and angle 6. They alternate sides. One thing we need to note on here is that they are also congruent. So I'll draw my symbol. So I could say angle 3 is congruent to angle 5, and angle 4 is congruent to angle 6. Remember, that's the symbol for congruent. And another word for congruent is equal. The next one is alternate exterior angles. They are on opposite sides of the transversal, but they're outside. So this time I know I'm looking at 1, 2, 7, or 8. Okay, so if I say angle 1, alternate to angle 1 and exterior would be angle 7, because it's on the opposite side of my transversal. If I say angle 2, opposite side would be angle 8. And just like with interior, they are also congruent. Congruent has that nice little symbol. Just means they are equal. And the last one we have are corresponding angles. Okay, corresponding angles are in the same position on the parallel lines in relation to the transversal. So I put here, think of Foursquare. So if you played Foursquare in elementary school, you were in one of those boxes. So if I draw on my picture here, I technically have 2 Foursquare chords. So they're going to be the angles that are in the exact same position in terms of the Foursquare chord. So if I say angle 1 The player in the other court that's in the same position would be angle 5. Okay? They're in the same position on the parallel lines in relation to the transversal. They're both above one of the lines and to the left. But even more simple, they're in the same foursquare position. If I say angle 2, the player that's in the same spot in the other court would be angle 6. And I could keep going, 4 and 8, and 3 and 7. And just like the other ones, they are congruent. So I have all of my pairs listed here. So let's try some problems, maybe that look a little bit more complicated. So these lines are parallel. That one got a little squiggly, but I know they're parallel because they're going to have these darkened arrows on them. I have line A and B. Then I'm going to have one transversal, Q, and another transversal, R. So this one just got a little more complicated because I have two situations. My advice here is at any point in time, cover up part of your picture. So maybe when you're dealing with the top part, cover up R. And when you're dealing with the bottom part, cover up Q. So I have angles 1, 2, 3, and 4. 5, 6, 7, and 8, 9, 10, 11, and 12, 13, 14, 15, and 16. Super important to make sure your angles are labeled the same as mine. So the first one wants me to classify the relationship between 11 and 15. Well, 11 and 15 are both down at the bottom. So with my hand, I would cover up the top part of the picture. I would cover up line Q and everything above it. So 11 and 15. If I'm looking at those, let's first figure out if they're interior or exterior. Well, 11 is inside because it's between A and B. It's between my parallel lines. It would be interior. 15 is outside A and B, outside my parallel line, so it would be exterior. So if you need to, you can look back at your pairs as you're getting used to them. So I classified them as interior, exterior. They can't be alternate interior angles because they're not both interior. They can't be alternate exterior angles because they're not both exterior. So my only option would be corresponding. Well, if I were to draw my foursquare courts here, do you see that player 11 and player 15 are in the same court? So I could say angle 11 and angle 15 are corresponding angles. Okay, and I could also say that because they're corresponding, angle 11 is congruent to angle 15. All right, so the second part goes one step further. Angle 15 is 78.5. It wants me to find angle 11 and angle 9. Well, if I look at 15 and 11, I just related those two together. I said that they were congruent. And another word for congruent meant that they are equal. So, if 15 is 78.5, that means 11 is 78.5. Now we got to relate this 9 somehow. Well, look at 9 and 11. 9 and 11 are opposite of each other, so aren't they vertical? And we know that vertical angles are equal. But also, if you look at 9 and 15, they're alternate exterior angles, and I know alternate exterior angles are congruent. So I could say the measure of angle 9 equals 78.5 because it's vertical to angle 11, and alternate exterior to angle 15. So either way you look at it, they're congruent. So they are all 78.5 degrees. All right. This one says angles RVT and UVW are vertical angles. So the measure of RVT is 3x and UVW is 5x minus 36. Wants us first to find the value of x. Well, if I look here, I know that they're vertical. And I found out from my definition of them being vertical that they are congruent. Another word for congruent is equal. So let's set them equal to each other. RVT was 3x. UVW was 5x minus 36. So let's get our variables to one side, numbers to the other, and we can solve for x. 3x minus 5x gives me negative 2x. Divide both sides by negative 2 to find that x equals 18. So the last part says solve for UVW. The measure of angle UVW was 5x minus 36. Well, I just found out that x is 18, so I'm going to plug that in. 5 times 18 minus 36. And I'm going to solve to find that UVW is 54 degrees. So it doesn't ask me, but if it asked me, I could also say RVT is 54 degrees because we know that they're vertical and we know that they are equal. So at this point, that concludes section 1 of chapter 11, Angle and Line Relationships.